NewsReader, System Architecture and Data Formats. NewsReader aims to identify what happened to whom, when and where in millions of news articles. Extracted information is stored in a structured database so that precise search can be carried out over immense amounts of data. This is a picture of the overall NewsReader architecture. In this presentation, we will walk through this architecture, explaining the process of going from documents to visualizations of structured data. There are presentations about several individual components available. They will be mentioned during the presentation, and the list of these videos will be provided at the end. Let's start with the input. Documents from various sources are converted to basic files in the NLP annotation format, or NAF, as shown here. These NAF files contain an element called raw. This element contains the original text in UTF-8. There is also a NAF header, where metadata provided with the original input can be captured, including the author, the publication date, and if available, information about the publisher, the newspaper or magazine that published it, or the location of publication. The first step of our process is to apply linguistic analysis for event extraction to these documents. When processing English text, we apply 19 modules for linguistic analysis. We also have pipelines for processing Spanish, Italian, and Dutch. A reference to a video presentation about the pipelines will be given at the end of this presentation. There is also a video presentation about how we optimize processing through parallelization. The outcome of linguistic analysis are stored in NAF. We will illustrate this through our input example. NAF is a layered, extensible annotation format, following the principles of the linguistic annotation framework. The first module of the pipeline, the tokenizer, adds the first layer to NAF, the text layer containing tokens. Each element in a NAF layer has its own identifier. These identifiers allow new layers to refer to information provided in existing layers. Here we see the term layer that is created by the part-of-speech tagger. Each term refers back to one or more specific tokens. All modules in the pipeline add information to the document's NAF structure. This can be done by adding a new layer, for instance, by the named entity recognizer, which adds an entities layer, constituents parsers, which add phrase structure trees, or semantic role labelers, which add predicates and their semantic roles. Other modules add information to existing layers. For instance, the named entity disambiguation model adds DBpedia links to entities in the entity layer. Or we add information about FrameNet frames or prop-point classes and roles to the semantic role layer. This leads to NAF files containing a vast amount of linguistic information. These files are stored in the knowledge store. They also serve as input for the NAF to SAM and NAF to GRASP analyses. These analyses result in our structured data in RDF. In this step, we apply the IDAP method. Events in NAF are identified. When the same event is mentioned at several places, it is represented by a single instance, leading to deduplication. Because information provided by these different sources are all linked to this single instance, this step also gives us aggregation of information. Finally, we capture which source provided which specific information. This gives us the means to explore various perspectives on the same event. We will now look at the data model used to represent the information obtained through the IDAP method. We use the simple event model SAM for representing events, and the grounded annotation framework and GRASP to represent sources and their perspectives. We will use the following examples to illustrate our model. The sentence based on an actual example in our data, Dieter Zetsche said that Chrysler expects to sell 5,000 SUVs, and the invented example, Manfred Bischoff says Chrysler will probably not sell 5,000 SUVs. We start with a simplified overview of the overall data representation. We can distinguish three layers in this representation: the instance layer, the mention layer, and the attribution layer. We will go through each layer individually, starting with the instances. As mentioned previously, we used a simple event model to model events. SAM provides a basic architecture for representing events and their participants, their location and time, as well as possibilities for further specifying the kind of event, the event type, the kind of role an actor has, the actor type, etc. In NewsReader, we use, among others, PropBank and FrameNet, as well as the specially designed Event and Situation Ontology, ESO, to provide additional specifications on the kind of event. There is a video presentation about ESO. Now let's go back to our example. The instance layer contains what the article talks about: the events, participants, time and locations. Each event or participant is represented by its own unique identifier. In this case, we have a commerce sell event, with Chrysler as the seller and 5,000 SUVs as the goods. The sell event is the message of a saying event with Manfred Bischoff as the speaker. And it is the expectation of Chrysler in an expectation event. Finally, the expectation is the message of a statement where Dieter Zetsche was the speaker. Now let's add the mention layer to this representation. Each instance in the instance layer is linked to the places where it is mentioned. This is done by the denoted by relation, originally introduced in a grounded annotation framework developed within NewsReader. Note that the instance layer only contains one representation for the commerce sell event and for Chrysler, even if they are mentioned several times. For reasons of clarity, mentions are represented by strings in our picture. But in our model, each mention is represented by a unique identifier based on its document and nav ID. This is necessary for representing the source and perspective information. We are now looking at the mention and attribution layers. Each event mention is linked to its own attribution identifier. Attribution identifiers are used to indicate the factuality assigned to a specific mention by a source. It can also provide information about the source's sentiment or opinion, if expressions are not neutral. In this case, we see that the example sentences confirm that the expectation and statements have taken place, without expressing any doubt about their occurrence. These attributions have the value certain positive non-future. There is some doubt expressed about the selling that will occur in the future. With Chrysler making it probable to occur, receiving probable positive future as a value, and Bischoff stating that it will probably not occur, with probable negative future as a factuality value. We can also indicate the source of statements. When sources are explicitly mentioned in the text, they are represented in the instance layer, and attribution identifiers are linked directly to them, as indicated by the red arrows. Other statements are linked to the article they were published in. When information about author and publisher is present, this will also be linked to the article. We thus provide a complete provenance information of each statement. We have now seen all three layers and are back at our overview picture. Note that we can extract the different perspective on the commerce sell event by comparing the attribution values of the individual mentioned referring to the event. The IDEP method translates all NAV documentation to GRASP and SAM representation, and this is stored in a knowledge store. There is a video presentation about the knowledge store. Visualizations can either directly use the RDF and NAV representations from the knowledge store, as is the case for the Cinescope visualization tool. We also have visualization that use other representation formats, such as JSON or SCV, for which we convert RDF presentations. This brings us at the end of our walkthrough. Here is a final overview of the data formats we have seen. NAV, a layered extensible annotation format for representing linguistic annotations. SAM, for modeling events, their location, time and participants. And GAV and GRASP, which together link instances to the places where they were mentioned and then indicate perspectives by providing the source, factuality and sentiment over the mentions. The overall system we have just presented is a joint effort by many researchers that are part of the NewsReader team. Here are the main researchers working on the data formats we have seen. Finally, please find an overview of videos presenting individual components of the pipelines here.